equal the initial momentum. Like the final momentum took a lot longer to equal the initial momentum, and so there wasn't this shock factor that cracked the egg. So here, your conservation of momentum is going to be a vector quantity. It is really dealing with a short interaction or a small impulse like crashes or collisions. And then it's easier to keep track of and it's easier to measure than energy. Now, I tried to read this over and over again in Khan Academy, and it sort of made sense to me, but it's still kind of a hard concept. But people use conservation of, or I guess physicists use conservation of momentum to really understand how objects move, because it is easier to track momentum than it is energy. Yes?
So does this thing answers the question that why is momentum conserved?
Yes. That was a question?
Yeah, that's what I was asking.
Oh, okay. Well, yes. Yes.
That's the answer for it?
If you want a more in-depth answer, it's definitely, like, Khan Academy does do a good job of explaining it, but it's still a complicated concept. So, but the whole point is, it's much easier to track the change in, like, conservation of momentum than it is to track energy. Even with your roller coaster, because roller coasters deal with energy, it was a little bit easier to do energy with that. But for a car crash, because there's so many different factors into play when dealing with energy, that it's hard to keep track of all of them, hard to be accurate with that. So momentum is what's used to really keep track of objects' motion and just things like that. So yeah. Because, yeah, even immovable objects have changed momentum as well. That's why. Conservation of momentum has